to the Cisco VXLAN Master Series. In this series, we are going to talk about the Cisco VXLAN, and I will be performing multiple VXLAN labs from scratch to advanced level. This is the day one of the series. This is the day one of the series. And before proceeding with the labs, let's first discuss what is Cisco LAN and why do we need it. So our first question is, what is Cisco VXLAN? So Cisco VXLAN basically stands for Virtual Extensible LAN. So what it does, it basically extends layer 2 network over layer 3 IP network using encapsulation. So in simple words, if I'll say it carries the MAC address, it carries the MAC address inside the IP network. Okay, so this is what VXLAN is. Next question that I'll talk about in the Cisco VXLAN is, why do we need Cisco VXLAN? So the simple answer is, the reason for introducing the VXLAN is, in VLAN we have some limitations. So I'll be talking about the limitations in the VLANs. First limitation is, VLAN is a 12 VLAN provides a 12-bit network ID, which means we can create only 4096 network segments. So with this much network segments, we cannot entertain every users on the cloud, as we have million of users on the cloud or in the data center. Correct. Second limitation is STP. So STP, STP, right? Everyone knows STP, spanning tree protocol. Spanning tree protocol. So what it does, it blocks the redundant path in order to provide a loop-free environment. Okay, it provide a loop-free environment. But parallelly, while blocking the redundant path, it does a lot of wastage of the links. So just suppose this is the path, so it will be blocking this link. All right. So this link will be the wastage of we'll be having the wastage of this link, right? So this is a main limitation of VLAN as well. And third one is VM mobility. So suppose we have a VM in rack 1 and I want to move it to rack 10. We have a just suppose we have a VM that is in rack 1 and I want to move this VM to rack 10 or maybe on rack 20. So in that case, whatever the VLAN is assigned to this VM in the rack 1, we need to have that VLAN in rack 10 and 20. So which is basically an issue, as we need to create VLAN and do the trunking and like do the manual work, right? So with the VXLAN, with the VXLAN, uh, like we are solving these issues. Okay, so first thing, if I'll talk about in VXLAN, we have 24-bit network, which means we can create more than 16 million network segments. All right. Second thing, uh, there is no concept of STP. Okay, there is no concept of STP exist in VXLAN, as VXLAN runs on layer 3 network, in which we have like all the links active simultaneously. Okay, so in the layer 3 network, so just suppose this is our layer 3 network. Okay, in this case, we'll be having all the links actively, we have all the links active simultaneously. We do not have any STP to block this link or this link or any other link. Correct. The third issue that we were facing with the VM is the mobility, VM mobility. Correct. So in VXLAN, VM can keep its IP address anywhere in the DC, and it will work. Like how it will work, we'll discuss in the later series. But this is the issue that it is getting resolved with the VXLAN. Okay. Now let's talk about the terminologies which we are going to use in the VXLAN. So first thing first, uh, in the VXLAN, just a sec. In the VXLAN, we have something called VTAP. VTAP stands for VXLAN Tunnel Endpoint. It is basically the device that will be encapsulating and decapsulating the VXLAN packet. So it is basically the leaf switches. So just suppose this is the topology that we will be using in our environment. This is the spine 1, this is the spine 2, we have leaf 1, we have leaf 2, we have leaf 3. So these leaves will be the uh, will be our we can call these leaves as a VTAP. Okay. Now the next thing is VNI. So VNI stands for VXLAN Network Identifier. So VNI is similar to VLAN ID. It is a 24-bit ID that can range from 0 to 1677 215. Okay, this is the range. And so, like, if I'll talk about we need in the VXLAN, we need a VLAN to VNI mapping. What that means is, if we have VLAN 10, then I'll be creating a VNI that is 10 10 10. Okay, if we have VLAN 20, we'll be creating a VNI with, with the ID of 20 20 20, and I'll be mapping VLAN 10 to VLAN 20, 10 10 10 and VLAN 20 to 20 20 20. Okay. Third thing is NVE interface. So it stands for network virtualization H. So it is basically the logical interface where VXLAN run. This is basically the tunnel interface. So we can think like it is similar to the loopback interface. Okay. So the way we have the loopback interface on our switch, we can think NVE interface as a loopback interface, but this is specifically for the VXLAN. Okay. So this is the tunnel interface. Okay. Moving forward with the fourth terminology, that is underlay network. So underlay network is, I'll say, the pillar of the VXLAN. So in order to run the VXLAN, we should have the reachability from all the devices to all the devices. So this network we called as an underlay network. So in our topology, spine 1, spine 2, and spine 1 and spine 2, leaf 1, 2, and 3, we'll be creating an underlay network using OSPF. Okay, and I'll be using OSPF as an underlay network, and with the help of OSPF we'll create an underlay network. Last but not the least, overlay network. So it is basically a layer 2 network which will be using on top of underlay. Okay, so whatever the traffic that will be going on the top of underlay, so just suppose this is the underlay network, and whatever the traffic that is going on top of underlay using underlay, will be calling it as a overlay network. So you can think it like as a underlay, and this one is overlay. Okay, so these are the major terminology that belongs to the VXLAN. Now the next part is, let's first discuss about the methods of VXLAN. Okay, so VXLAN has two learning method. First one is a static method, which we called as a flood and learn method. Second one is a dynamic method. where we'll be using BGP EVPN. BGP EVPN control plane. Okay, so just a sec. Let me remove everything. And okay, so first talk about the static method. And let's first talk about the static method. So it is basically the flood and learn method. Flood and the learn method. In this method, switches do not know about where the MAC exists. Okay, so in this, it is kind of a old method. So how it will work? Firstly, all the switches flood the traffic like we do the flooding in the VLAN. Second thing, when the traffic reaches to the remote VTAP, I'll say the switches. Okay, remote. Whenever I'm saying VTAP, it is basically the switches, leaf switches. Whenever it is reaching to the remote VTAP, so repl remote VTAP will reply to this packet, replies to this packet. And third one, it learn the MAC from the data plane. So once the traffic, so just suppose if I'll explain you in this topology, spine 1, spine 2, leaf 1, leaf 2, leaf 3. So whenever the leaf 1 try to send the packet, it will flood the packet to all the devices. Okay. When the packet reaches to the leaf 2, which is the VTAP, it will reply back with the answer. Okay, I have this MAC address, and what it does, it will learn the MAC and it will store in its table. So this is kind of a flood and learn method. So firstly we are doing the flooding, and then layer 2, oh sorry, VTAP leaf 2 is learning the MAC address of the another host. Okay, so in this method we manually need to configure peers. We manually need to configure manually configuration of the peers, or we'll be using the multicast group. I'll be talking about this in the upcoming videos, like we'll be performing the lab for static VXLAN in the next lecture. Okay. There are some problems with this method as it does massive flooding, and it is not scalable. The reason why it is not scalable, see, the moment leaves increases, we need to do a lot of manual configuration for every leaf, and this will be very hectic. Correct. So in order to resolve this issue, we have the another method that we called as a dynamic method. Okay, which is the EVPN method. Okay, in this method it uses BGP EVPN control plane instead of blindly doing the flooding. Okay, in this method leaf learn locally which host or MAC address is connected. Just a sec. So in this method, in this EVPN method, leaf learn locally which host or MAC address is connected, and it creates a table and advertise that details using EVPN route type 2. So what I'm trying to saying is, spine 1, spine 2, leaf 1, leaf 2, leaf 3, and, just suppose there are hosts connected to these leaves. Okay. So in this method, what it does, leaf 1 will learn, okay, what MAC address, just suppose this is the MAC address A. Leaf learn, okay, A is connected to, just suppose this is the interface 1/1. Leaf 1 will create a table, okay, MAC address is connected to 1/1. So what it does, it create a table, okay, and it advertise a table to all the leaves, this one and this one, using a special route type 2. Okay, so in this case, this information, okay, A is connected to 1/1 on leaf 1. This information will be replicated to layer 2, sorry, leaf 2 and leaf 3. And just suppose A host that is connected to leaf 2 will try to ping the MAC address A. A host that is having a MAC address A, it will not do the flooding. It will simply forward the packet to leaf 1, and leaf 1 will reply on that packet, and this is how it works. All right. So this is all for today. We'll be talking about other concepts simultaneously while doing the lab. I'll be doing the lab from scratch to make sure like everyone will be aware of VXLAN and can perform the same in their environment without any issue. So in this lecture, I'll be discussing in the next lecture, I'll be discussing about the static VXLAN method, which is flood and learn, and then we'll move accordingly. So thank you guys. This is all for today, and see you in the next lecture. Thank you.